The Morgan's chopper. Morgan chopper is having the advantage of using a single SCR. It employs in class B commutation, also known as current commutation or resonant pulse commutation. Morgan chopper uses the saturable reactor SR, here it is, for low values of exciting currents, after which it offers very low or negative inductance. The saturation polarity of a reactor depends on the direction of the exciting current. Either it can be a positive or a negative. Let us see the operation of the Morgan chopper. Mode 0, let it be. When main thyristor T1 is off, the capacitor charges to a VDC. As this link is not there and SR is positively saturated. In this mode, if you observe, the current flow is from VDC plus to C through SR, through inductor, through the load, back to VDC negative. Here, the load current is supplied by the inductance. Mode 1. When the thyristor T1 is filed at T equals to T1, you can observe in the waveforms, the voltage across the capacitor appears across saturation reactor through T1. So now the current is flowing from C plus to T1 to saturation reactor back to C negative, due to which the core flux direction in saturation reactor changes to negative saturation. Now the SR changes its polarity from positive saturation to negative saturation during this period. As soon as the saturation reactor changes completely to the negative from the positive saturation, the capacitor C starts discharging through thyristor T1 SR, forms a resonating circuit. So the discharge period of time TR is given by pi square root of Ls of C, where Ls is the post saturation inductance L. As this time TR is small, so the polarities of C is reversed quickly. So at the end of this, the VC polarities changes. Now right side one is positive and the left side one is negative. Now the voltage across the capacitor is minus VDC, which is applied across the saturation reactor, results in the change of the core flux direction of the saturation reactor from negative to positive. In mode 0, it is in positive. And mode 1, when T1 is turned on, the polarities of saturation reactor changes from positive to negative, and then resonating circuit is formed between C, T1 and SR, and the current flows in the reverse direction and the capacitor charges in reverse. Then the polarities changes. As the polarities changes, right side will become positive and left side will become negative. Then the SR again changes its polarities from negative to positive at the end of the mode 1. Now the mode 2. As soon as the saturation reactor is driven to positive saturation, the capacitor C starts discharging again through C plus SR T1 to C minus in reverse direction. This current is applied across the thyristor, due to which T1 turns off. At the time T equals to T2, you can observe in the waveform. Now discharge current starts flowing through the diode D as soon as the T1 turns off. Then the average output voltage V0 falls to 0. But L opposes the sudden changes in the current. It starts releasing the energy stored by inducting EMF of the reverse polarity. Hence, I0 flows through the DF. So at the end of mode 2, T1 is off and VC is charging again. So I0 flows through the freewheeling diode. Now output current I0 is from source when thyristor T1 is on. When T1 is off, I0 is due to inductor L flows through the freewheeling diode DF until the thyristor T1 triggered again. So overall summary of the Morgan chopper is, the first one, the time required to saturate cores is constant. Now second one, The conduction period of T1 is fixed and depends on Ls and C. Ls is the post-saturated inductance, as Tr is dependent on Ls and C, and determined by the time required by the saturated reactor to change from positive to negative saturation and vice versa. Now the third point is T on time of the T1 is constant as the course saturation depends on Tr. Fourth key point is the average output voltage V0 can be attained by changing the output frequency or the time capital T. This is regarding Morgan-Chopper working. You can observe different states of the time in the waveforms